All right, and so in this section, we're going to be talking about piecewise functions. But to get started, we're actually going to start by talking about the library of functions. Now, I'm going to refer to these as parent functions or functions that have had nothing transformed on them. We're going to start off with what's known as the constant function. So this is the constant function. The constant function is simply f of x is equal to b, where b is your y-intercept. So b is simply where it crosses through the y-axis. Another way that we've learned this is that b is, or f, the constant function is a horizontal line. Okay, so a constant function is simply a line. Now, the next one we're going to talk about is called the identity function. The identity function is simply a linear equation with a slope of 1. Okay, notice that the identity is positive and it goes through the origin. Okay, and then we also have a square function, which is the basic x squared. Then we have a cubic. Then we have a square root. Then we have a cube root. A reciprocal, which is just a rational equation. Absolute value, and then we're not going to do a whole lot with integer functions, but in case we do talk, in case you do have something to refer to, you got that. So this is more or less just a reference page. Now let's go ahead and take a look at this first example. It says the function f is defined as f of x equals negative x plus 1 when x is between negative 3 and 1, 2 when x is equal to 1, and x squared when x is greater than 1. Okay, so when we're evaluating these, what we're doing is we're looking at what the x values are, right? So we've got, over here we've got x equals 0, x equals 1, and x equals 2. Okay, and we're going to look in our domain to determine where those fit in. So looking at this first one, f of 0, you'll notice that 0 is in between negative 3 and 1. So we're going to plug it in to this equation here. So it's going to be f of 0 is equal to negative 0 plus 1. Well, negative 0 is just 0, plus 1 is 1. Okay, that's all we're doing here. So now, if we're looking at this next one, f of 1, okay, when x is equal to 1, so when x is exactly 1, we know that the solution is simply 2. So f of 1 is equal to 2. Okay, and then the last one, we've got f of 2 is equal to, right? And so now we've got our x is greater than 1, so we're going to plug it into x squared. So we've got 2 squared, well, 2 squared is 4. Okay, now determining the domain, I'm going to go ahead and erase all this information here. Our domain, we're not worried about this information here, okay? Our domain is going to come from these numbers. Now, notice that the smallest, so if I'm writing our domain, the smallest value is negative 3. So we're going to start at negative 3. Okay, and the largest value, notice that x goes all the way up, and it's greater than 1, so it's going to continue on to infinity. Okay, now, if we're using interval notation, notice that we have this or equal to here, so we're going to block that negative 3 in with a bracket, and then we've got parentheses always around infinity. If you prefer to use set notation, it would be the set of x such that negative 3 is less than or equal to x. And that's all we have to do there. All right, so now we're going to take a look at the graph of this. All right, so the first one we're looking at is this first block. Okay, so notice that it's on the interval from negative 3 to 1. So that goes from right here all the way up to 1. This is the only part of the graph that we're worried about. All right, so let's graph that. So we've got negative x plus 1. Okay, so I'm going to go I've got my y-intercept is 1, so we're going to go up to 1. It's negative x, so it's going to go down 1 over 1. And then it's going to go, I'm going to put a little dot here. It's going to go down 1 over 1. It's going to go up 1 over 1, up 1 over 1, up 1 over 1, until we get back to negative 3. So we have this line right here. So this is our negative x plus 1 graph. Now we do need to figure out what the endpoints look like. So remember, if it's a or equal to, it's a solid dot. If it's just less than, it's an open dot. Okay, so at negative 3, I'm going to put an solid dot. And at 1, I'm going to put an open dot. All right, then it says at x equals 2, f of x is equal to 1. If x equals 1, then f of x equals 2. Okay, so this would go with point 1, comma 2. And because it's an equal to, I can simply put a point there. So it's at 1, comma 2, I'm going to put a solid dot right there. All right. And then lastly, we have x squared if x is greater than 1. So x is greater than 1 over here. Okay. So we're going to need to come up with a few points. Now remember that this is an x squared term, So we're going to be using this square function here. Notice on the square function that at 1, it goes through this point. Okay, and then at 2, it goes up through this point. Okay, and really that's all we need to do. If you want to, you're more than welcome to go through and take a look at maybe doing a t-chart, but you don't need to. All right, so if we were to graph this, remember it goes through the origin, and it goes through 1, 1, and I'm putting little dots here. And then at 2, it goes up through 4. Okay, and again, I'm putting a little dot here. If my tablet will work with me. There we go. Okay, and so I'm going to draw my line. It's going to be kind of a small curve, and I'm going to draw an arrow because it does continue. All right, now we do need to figure out whether that's an opened or closed circle. So we're going to go back over here, and at 1, it says it's less than, right? So it's going to be an open circle. So we're going to put an open circle right here. So at 1, we have an open circle, and a closed circle. Remember, you only put closed circles where there are, where it has an or equal to under it. All right. So now it says use the graph to find the range of the function f. Okay. So we're going to take a look. I'm going to change colors here. We're going to take a look. Now notice that the lowest point that it goes, so remember that you use lowest to highest. Okay. So the lowest it goes is actually at y equals 0. Okay, so I'm going to say range. And I'm going to start at y equals 0. And also notice that it goes up, and it has all of our empty spots are covered, and it has an arrow at the end, so it goes up to infinity. Okay, infinity's never bracketed in. Now what about this 0? Notice that at 0 we actually have an open circle. So that means that we're going to put that there. Okay, and again, if you prefer set notation, it's a set of y such that 0 is less than y. Okay, and then is the domain continuous? To be continuous, it just means that there's no skips. So in other words, if it were continuous, it would have no spaces in between these. So our answer would be no. Actually, sorry, this is COVID brain. The answer is yes. It is continuous on the domain because there are no gaps in our graph. So the answer is yes. No gaps on x values. So in other words, we can pick any x values greater than or equal to -3, and we'll be good. All right. So let's look at this word problem. It says in May 2006, Commonwealth Edison Company supplied electricity to residents for a monthly customer charge of $7.58 plus 8.275 cents per kilowatt hour for the first 400 kilowatt hours in the month, and 6.208 cents per kilowatt hour for all usage over 400 kilowatt hours in the month. The first thing we're looking at is what is the charge for 300 kilowatt hours in a month. Okay, so notice that this is actually underneath that first 400 kilowatt hours. So the way we can calculate this is by simply saying we have a base charge of $7.58 plus we need to convert this to dollars, right? We can't have two different signs. So this would be 0.08275 times 300 kilowatt hours. And that gives us approximately $32.41. Okay, so for the first 300 kilowatt hours in a month, you would be expected to pay $32.41. Okay, now what is the charge for using 700 kilowatt hours in a month? Okay, well, in this case, we're going to have to take $7.58. Okay, again, this is our base charge, plus 0.08275 times the first 400 hours are at this rate, so it's going to be times 400. Now we have an additional 300 kilowatt hours left over, so that additional is actually going to be at that new charge, so at that lower rate, so 0.06208 times 300. And now we get, I'm going to write this up here. So we get a charge of $40.70 for 700 kilowatt hours. Okay. So again, this is kind of a way that you would use piecewise functions in real life, is where in rate changes. All right, so now it says, if C is the monthly charge for X kilowatt hours, develop a model relating the monthly charge and the kilowatt hours used. That is, express C as a function of X. So remember that whenever I say express C as a function of X, all I'm saying is that we're going to say C parentheses X. So it's a C, the cost as a function of X, equals. Okay, and notice that there's two different charges here. The first one up here, and then the second rate. Okay, so the first rate's pretty easy to come up with. It's simply $7.58 plus 0.08275 x, and that's going to be, and we'll figure out our domain here in just a little bit. All right, the next part's what's going to take a little bit of extra work, a little bit extra thought. All right, so we have $7.58 plus 0.08275 times 400. Okay, so this represents the first 400 kilowatt hours, right? Because we're talking about two different rates here. Okay, so now let's go ahead and calculate the second one. And the second one's actually going to add on because we're still paying, even if we've gotten up to the 400, we're still paying for that 400. All right, so now let's take a look at the next one. So the next one, the way we calculated part B is we have the first 400 kilowatt hours plus the second rate times the amount of kilowatt hours that we have left over. Okay, so the way we could do that is by saying plus 0.06208 times Well, the way we find out how much is left over, I'm going to take the number of kilowatt hours, and I'm simply going to subtract 400. All right, next, I'm going to simplify this. So, simplifying this, well, the first part, we know that the first 400 kilowatt hours is $40.68. Okay. Plus 0.06208x plus $24.80 that. Okay. And so again, this is just me simplifying. So this is again the first 400 kilowatt hours. All right. And then finally, we're going to combine terms. And I apologize, this should be minus. All right, so we're going to combine like terms. So I'm going to combine these two things. And we have 0.06208x plus $15.84.8. All right, and so we have both of our equations. We have the first model, and then we have the second model, which the second model will be 0.06208x plus 15.848. And now the last thing we need to do is simply figure out what those domains are, what the intervals that those values hold true. Okay, and this is typically the easiest part. So remember that this rate up here actually only applies for the first 400. So I'm going to say that it's from 0 less than or equal to x less than or equal to 400. Okay, so this represents the first 400 kilowatt hours. Then anything bigger than 400